Hey guys, it's Miss Marflack here. We're going to graph our log function. Now we're going to be graphing it with transformations. So if you haven't seen the first video where we have no transformations and we did those 5 examples, you really need to go back and you need to look at that video first, or this video will be very, very confusing. We're going to graph it the same way we did in the last video, and then now with the transformations, we're going to be taking those skills that we learned from that transformations packet, and we're going to be shifting our x values and y values left, right, or up and down, depending on each example, and we're going to do that using the table of values. So we're first going to start off with our parent function here, and our parent function is that y equals log base b of x. So no transformations here. B can be any number, but we have nothing in parentheses, nothing moving left, right, up, and down. And then now we're going to take a look at what our equation looks like when we do have transformations, and this should look really familiar, especially the different variables we use here. We saw our a is our stretch and compress, and then we have our x minus h in parentheses, that's our left and right, and then our k is that up and down. So quick refresher, if you're comfortable with this, fast forward the video. If you're not, pay attention. Here we are, absolute value of a when it's greater than 1, that's our vertical stretch. When the absolute value of our a is between 0 and 1, that's our vertical compress. When we have that negative a, that's our reflection over the x-axis. And then now when we have our h, that's our right and left, keeping in mind that the minus sign is in the formula. So when you have a positive h, you're moving right. For example, x minus 2 would be right 2. When you have a negative h, so when you have x plus 2, that is going to be moving left. And then we have that plus sign with the up and down. So then we just take the same sign for up and down. Now, I know when we did transformations, we did all of these, but really, honestly, we're going to be taking a look at these too with our log function. So you really won't see probably anything in front in your homework. You won't see any negatives. You'll just see moving left, right, up, and down for that table of values. All right, we're going to get started here with our first one. And I'm going to actually number this number 6. Because in the last video, we did 5 examples, so you should have 5 examples of graphing logs in your notes, and here we are picking it up with number 6, and now we do have a transformation, and that's log base 6 of x minus 2 plus 3. All right, just like we did in our transformations packet, the first thing we're going to do is we're going to graph the parent function, which is 6 to the y is equal to x. If you need to rewrite this as y equals log base 6 of x with no transformations to scoop and loop, that's fine. All right, but here we can just see that that's base 6, and then here's our parent function. Now, we did graph this in the last video, so I'm going to do this really quickly, putting that negative 2 to 2 because we are not shifting yet. And then filling in those values. Now we're going to get an estimation here for that 1 over 36. Well, that's going to be, 0 point, what do I have in my notes? 0.27, and I believe the 7 keeps repeating, and then the 1, 6, that's 0.16, and the 6 keeps repeating. All right, and now we're going to graph our transformations. And looking at what we have inside of our parentheses, that h is positive. This means that we're moving right 2. And then the 3 outside of the function, that's our y values. That means we're moving up 3. So our new x and our new y is going to be our old x and our old y now with these transformations. So I'm taking 1 over 36 or 0.027, I'm moving right 2. If I'm moving right, I'm increasing, so I'm adding 2. All right, and the same thing here. I'm adding 2 because I'm moving right. I'm adding 2, and then the 38 will be off the chart, off the graph, I mean. All right, so there we are. We added 2, and then now we're going to take all of our y values, and we're going to add 3. So that's 1, that's 2, 3, 4, and 5. All right, so just like we did in the transformations packet, you're starting with the parent function, always doing the table values for the parent function, and then shifting each individual point. Right means we're increasing, left means we're decreasing, up means we're increasing, down means we're decreasing. And then I did already graph this for us. Like I said, if you do have a printer, it'd be really, really good to kind of print this out, and that'd be really helpful. If you don't, that's okay. All right, so you could see here in the blue, I did graph the parent function, which you did in the last video, and then now in the purple, I graphed the transformations. And then if you look at each individual point, I'll get a different pen here, each individual point, like let's say I start on this point, all right, and I want to move right 2, 1, 2, and then I go up 1, 2, 3, there's my point. All right, same thing, starting here, I'm going to move right 2, 1, 2, and then I go up 3, 1, 2, 3. Same thing, I go right 2, 1, 2, and then up 2, 3. So you can always just graph the parent function and individually transform each point, or I really would like to see this table of values here. All right, we're going to do one more in this video. If you don't have this down, pause it because we're doing the next one. Okay. Taking a look now, so we did 6. This one's going to be called, you guessed it, number 7. All right, here we are, number 7. We did a whole number base, so now we're going to do a base as a fraction. In the last video, I wrote that as 0.5, and then now we're writing that as a half. All right, just like the last example, we're starting off with that parent function. So I need to see the parent function, 1/2 to the y is equal to x. And then we're picking those y values at -2 all the way to 2. Plugging the -2 in, we get 4. Plugging the -1 in, we get 2. 1 here, and then 1/2 and 1/4. All right, if you're not comfortable with that, that's okay. Use a calculator, and then we're going to estimate the 1/2 to be 0.5 and the 1/4 to be 0.25. All right, now looking at our rules for transformations that we did a little earlier, that's up here on our notes, we can see that inside our parentheses, we have an x plus 1, which means that our x values have moved left 1. All right, and then we have a -2 on the outside, which means that our y values have moved down 2. So we're going to take all these x values and we're going to move them left 1, which means I'm starting at 4, I'm moving left 1, I'm decreasing. I'm starting at 2, I'm moving left 1, I'm decreasing. 1, I move left 1. So I'm going to be subtracting 1 from all these, and I can use the calculators for these last two if I want. All right, but there we are. We moved left 1, I subtracted 1 from each x value. And then now our function has moved down 2 units from the parent function, so I'm taking that y value and I'm moving down 2 units, moving down 2 units, down 2, and down 2. And then now we have a table of values to graph, and I did already graph this one for us. Try and fit everything in here. Okay, and there we are, number 7. And you can see I graphed the parent function. Go to my other pen. I graphed the parent function here in blue. That's this table of values. So we have that 4, -2, that 2, -1, 1, 0, a half 1, and a 4th 2. And then I graphed our new table of values in purple for our transformation. And we see here we have 3, -4. We have 1, -3, 0, 2, negative a half, -1, and then 0.75, 0, negative 0.750. And then I could see if I start on this point and I move left 1 down 2, I'm at my transform point. If I start at this point and I move left 1 down 2, I'm at my transform point. Same thing, I'm going to go left 1 down 2, I'm at my new point. Left 1 about here, down 1, 2, I'm here. Left 1 down 2. So you can, if you'd like, you can always just start with the parent function and transform each individual point. All right, hopefully this video helped. I really need to see you guys doing your homework, and you know, no taking shortcuts on your homework. Look at what I did here. I wrote out the function, I wrote out the parent function, I wrote out the table of values, I wrote the transformations, and then I transformed each individual point. Hashtag no excuses. Email me if you're confused by this, and I could do more examples. But you really should be pausing the video, going back, rewatching, doing whatever you can do to really understand this concept here. This is the last thing that we're going to be doing with the graphing. After this, we're moving on to log equations. So this is really the only lesson where we're getting some graphing in, so it is important to kind of understand this fully, and then email me if you have any questions. All right, bye guys.